Hello everyone, I'm Piotr working at ChronoLogic. We are a team that's working on the Ethereum alarm clock, which is scheduling transactions in the future. So I'm going to talk about the second layer execution markets, which is a basis for our protocol. Before we can start with the second layer execution markets, let me explain the delegated execution. Which is a pattern that's evolving now in the community. We see some projects using that, but essentially on a high level, this is a pattern that allows any third party to execute your transaction in exchange of some sort of reward. So we have the off-chain execution agents that are usually incentivized by some sort of reward, and this is in a very abstract way. This is some sort of payload that contains, for instance, the call data and the conditions that is either put into the signed message or on-chain storage. So as I said, we have two different flavors of the representation of the delegated execution. The one we're using in Ethereum alarm clock is based on on-chain storage. So we keep the scheduled transaction as a separate smart contracts on-chain. But you can also do this in a way by using the signed messages. And basically both approaches have some pros and cons. Signed messages are cheaper and more user experience friendly, but actually are also a little bit more complex. So yeah, let's get into the execution market. So essentially, the market exists because there is an incentive for the off-chain nodes to, scan the network in our case and execute transactions. And because of that, it's actually very, very interesting because it turns to be a very competitive. It does have some perfect competition characteristics. So these nodes who are looking for those transactions and execute them, they have essentially the same, everyone have the same information, and every of these nodes provide the same service to the network. We can also call that the execution markets provides the reliability. You can imagine that in a way that, if you want to schedule your transaction into the future, then someone is going to execute, some node is going to execute, for you. Then you can see that the more nodes available on the network, the higher reliability of the network itself. We can also see this market as a demand and supply. So demand is actually created by the executing agents, where the supply is created by the transactions and the bounties or the rewards that are put on the network for them. As mentioned, we observe now that there are at least a couple of the projects that are using this pattern or in a different variation. Obviously, scheduling transaction by Ethereum alarm clock. Gnosis Safe also using the same messages in order to interact with their wallet. Transaction relayers by Uport. Recurring payments for EIP 1337. Miximus, which is a on-chain mixer. But also, this might be used by the watchtowers, which are the third-party availability managers, providers for a Plasma and state channels. So this is kind of the observation on how the ecosystem looks now. So we have the Ethereum alarm clock and the network of the executing agents. We also see that some teams building around the ERC 948, which is EIP 1337, recurring payment subscription models. They're working on the same concept, and essentially many different dApps or protocols trying to use it, trying to bootstrap the very same network. So essentially, what's wrong with that, right? We think we are actually, those networks are, the silos, and what does it mean and why it's actually bad? So less bounties means the less nodes or less executing agents that are incentivized to perform the operations. Less nodes means the worse reliability. And from our experience, the setting up this kind of network is not a trivial task. So, it's rather hard, and you know, if we have the network that contains very few nodes, or maybe the nodes who are run by the dApp provider or by the protocol provider, then we think it actually hurts the decentralization, because there are some possibilities of the censorship resistance in that case. So. And this is something that we thinking in our team might be, you know, the good idea. So this is a sort of a pitch to all the projects that using and following this idea. So we think we should build together a protocol, or, you know, at least the EIP that's gonna create the homogeneous execution market. So what we essentially wanna do, and obviously wanna help with, is that we end up with one network with like multiple nodes from different projects, different people, serving the purpose of the delegated execution. Right, so obviously there are a couple of things that has to be done before we do this. So we have two approaches. One, ERC 1228 created by us for the on-chain delegated execution, but there is a wonderful EIP 1077 for the signed messages, so both are very relevant in the case. You know, the bounty representation, I'm going to talk a little bit later about that, but that's also an interesting case. And essentially we're building a decentralized network, so it would be great to have many different implementations for those executing agents. And the goal obviously is an easy onboarding for the new coming protocols and dApps. I'm going to talk a little bit, you know, about deeper about the ingredients or the components of this kind of execution market. And the first one is the incentivization. And here I'm going to talk about in the case of the deterministic execution. And what I mean by this is that we know when the execution should happen, right? So either this is now or maybe in the future, but essentially the time of the execution is known. So in this case, and in general, incentivization and this kind of protocols, they don't really guarantee the execution, right? So we can talk about the crypto economic guarantees for the execution, because that's the decentralized network. So, well, you can say that the higher the reward, the more likely the execution will be provided. Also, in the deterministic execution, we talk and we kind of define the thing like a execution budget, especially for the future transaction is very important because you don't know what would be the gas price in the future. So there is a need for some tricky algorithm basically to, you know, to allow the execution in the future, even in case of the gas price spikes. The other case that has to be taken into account is when we talk about the non-deterministic execution, and you can imagine this as a, for instance, the centralized stop-loss mechanism, which works in a way that you have the off-chain nodes that observe the state of the blockchain, might be the oracle or some other, you know, source of truth, and should execute transaction, in this case the stop-loss transaction, if any of the conditions are met. Yeah, but the problem with this is that you don't really know, and it's not predictable when this case will happen. So that's why we talk about the non-deterministic execution. And here, what we think is gonna be relevant is any of the rent models that you can apply for this, which means that you will pay the watcher or the executing agents, you know, based on the time. So if the stop loss will take in 1 month, then you will pay for the 1 month every day or every block or every some unit of time. But that's also actually comes with the problems, like withholding problem and bunch of other stuff that's due to the time I will not touch now. But interesting thing is the bounty or the reward, and what does this really mean? For most of the people that I discuss with is either, you know, Ether or ERC20 tokens. But what we think and what should this kind of, you know, delegated execution markets should support is essentially any upcoming asset that is going to be available on the network, right? So we have non-fungible tokens, which are huge and are, you know, very vivid in the implementation and availability. But also, what about the things like reputation, right? For instance, if you have a node that's executing some transactions, maybe the reward for this node would be the boost in the reputation system, which actually, when we go down, it abstracts to any code execution. So what we also put on the ERC repository is the meta payment idea, which is what we call pay to code. Yeah, the other important aspect is the communication. So I'm going to go through that very quickly. We have two flavors, on-chain and off-chain. With the on-chain that we're using on the Ethereum alarm clock, you have a couple of the options, and it's always trade-off between the complexity, the cost for the users. So, yeah, and the cost for the users. So either you use events only and emit the whole payload with the event. You might use some external storage, or maybe the smart contract storage as we're using. For the off-chain, so with the signed messages, it's slightly different and a little bit more complex, because you are not keeping your payload in a way like in a smart contract storage which is available, but you can use some decentralized storages like IPFS or Swarm. But there is also a need to build a messaging protocol to publish and to announce this kind of messages. And one remark is that usually in this kind of protocols, the destination is a chain, is the chain essentially. So you can take off some of the burden and price and complexity out of the on-chain execution, and provide the same result on-chain, but in a very cheap way. Yeah, the coordination problem, which is, I think, the hardest problem to be solved. So in our case, essentially, we define this as a collisions, and they actually happen because when you send some sort of delegated execution, like a transaction into the future, so you put an incentive or bounty to those nodes. So what you expect is that essentially everyone tries to get this bounty. And because only one of them can actually earn and successfully execute, then we see the situation as on the slide. So one time node or executing agent earns money, and some of them lose money because the transaction was reverted on the Ethereum network. Some of them might be just idle because they use like a pool watching and some other mitigation mechanisms. But just to sum up, it's not a zero-sum game, essentially, which is a problem. And there is a bunch of solutions that you can apply for the on-chain coordination games. But the problem with the on-chain coordination is that the complexity costs, essentially. So you can have good solutions, but they will render useless because of the high gas costs. So, and you need to understand that this kind of networks and nodes can exist, but because they are the rational agents, they will not exist if they just are not profitable in the long term or in the short term. Yeah, for the off-chain coordination, so we did quite a lot of research around that, and where we get into is basically very similar problem as for the Casper block producer. So there are a couple of the solutions, and here we're just following, and that's recommended to follow the development on Casper. Okay, so that was slides, and now I just wanna make a small announcement, because we've been working on the Ethereum alarm clock for months now, and it's actually available on the mainnet. So you can go to our dApp at chronologic.network today and schedule transactions into the future. So we're very proud and excited about that. Next week we're gonna be in my crypto wallet. So it's gonna be first-class feature on my crypto wallet. Also, if you're interested in running and executing agents for our network, just visit the ethereum-alarm.com. You will get all the information and tutorials and code and everything how to run it. So that's how it's going to look on my crypto. You can notice that there is a very nice send later switch that's going to be available next week. Okay, thank you for my talk. Thank you for having me.